You're welcome to yet another video. This time around, we want to discuss area and volume. Area and volume. What therefore is area? Now, I like to define area as the space occupied by a plane figure. Space occupied by a plane figure. Whereas I would like to describe or define volume as the space occupied by a solid figure. So, with this in context, what do we mean? What we mean by is when you try to talk about area, you are trying to talk about the space which is occupied by a plane figure, for example, a triangle, a rectangle, for instance, over here. So what the shape we have here is a rectangle, and this rectangle occupies a given space as we can see. So this given space occupied here by this rectangle, which is a plane figure, is called the area. So to find the area occupied by this plane figure, we will have to know the distance occupied by the length, which is usually the longest side, and the width. So we find the product of the L part, which is the length, and also the width. So assuming we are told that this part of the length is, say, 7 centimeters. So assuming for the rectangle that we have above, we are told that the length of this rectangle is, let's say, 7 centimeters, and our width is, let's say, 5 centimeters. Then our area can be defined to be equal to the product of 7 centimeters and that of 5 centimeters. So 7 centimeters times 5 centimeters. And that implies that our area should therefore be given as 7 times 5 to give us 35, and centimeter is present here twice, so centimeter squared. So good, sorry, centimeter squared. Note that because we are dealing with a plane figure, and two numbers are involved with the multiplication at any point, or two units are involved with the multiplication, our product is having a power of 2. Good, because we have 2 centimeters, one here and one here, one in the length and one in the width, multiplying each other. Similarly, in the case of the volume, talking about volume, we can say that to get the volume, we need a solid figure. So volume requires a solid figure. Volume requires a solid figure. So a solid figure. What therefore is a solid figure? Now, for identity purpose or for simplicity's sake, I always describe a solid figure to my students as if they should consider a figure or a shape which can actually stand on its own. Yes, a figure who can stand on its own. So assuming you are given a shape like this, so this shape can definitely stand on its own. If you're asked to put it on a table, it can stand on its own, and you can see all the aspects as expected. Now, in the technical, people will call this one a three-dimensional shape, whereas they also describe a plane figure as a two-dimensional shape. Good. Why do we say two dimensions? Because we have the length and then the width. The other parts are just likened to the identified parts. But when we come to the solid figure, they call it a three-dimensional shape because you see we can have one of the dimensions here, which is the height, and then we can also have this part and this part. So if you look at it carefully, let's even input that of a cube or a cuboid to get better appreciation of what we're trying to talk about here. So when we input a cube or a cuboid, you realize that with this shape we can identify the longest side here, which is the length. Then you can identify the height and also identify the width. Now if you look at it carefully, realize that you can identify three main parts: this part of the shape, the top part, and the side part, as we have here. So that is the case of a three-dimensional view shape, or better still, a solid figure. So you can only be required to find the volume of a solid figure. So in a question can be posed that assuming we have a sphere. Let's go for a cuboid, rather a cuboid of length 6 centimeters, then width 4 centimeters, and height say 5 centimeters. Find the volume of the shape. Good. So note that we said to find the volume you need a three-dimensional view object. So our volume will be obtained by finding the product of the length. So length, the product of the length times the width times the height. Good. So all these have been given in the question. So all we just need to continue what we have to do. So we can have our volume being equal to the product of, so 5, we have 6 centimeters, so 6 centimeters times 4 centimeters times 5 centimeters. Note that we can find our volume by finding the product of these numbers and also finding how many times the centimeters came and raise that power to the number of times it came. So 6, the product of 6 and 4 is 24. Better still, 4 times 5 is 20. 5 times, So 20 times 6 is 120. So the product of the three numbers will be 120. Then we have centimeters. So 120 centimeters. But note that the centimeters here came how many times? It was reported 3 times. It was reported 3 times. So we have to find the power to complete our process. So centimeters cube. Centimeters cube. Note that, let's simplify it this way. So our volume will just be, volume is equal to 120 centimeters and cube. Centimeters cube. And that is because our centimeters repeated itself 3 times. Thank you for watching, and it's bye for now.